Okay. So who is Cloud at Cal? It's Berkeley's first cloud technology and education student organization, spreading cloud technologies to students. And it's really important to CLAC that it's kind of regardless of their background or major. It's not just computer science students that are involved with Cloud at Cal. So let's get into what is the cloud. So there's like a raw, boring definition that you might just find like as like a dictionary definition, which would be delivery of information technology resources over the internet. But if we break that down a little bit and get into what it actually means by way of maybe some examples that you may have interacted with, you've probably used Google Drive, and you probably used iCloud if you have an iPhone or an Apple device. With something like, let's say, Google Drive, you might log in with your Gmail account and upload some files, write some documents, create some spreadsheets and all this. And then you may access your Google account from another computer all the way across the world. All you need is internet access. And if you do that, you'll be able to access all of those files from that other computer over the internet. So that's the delivery of a certain IT resource over the internet, specifically storage. And iCloud essentially is the same idea. It's delivering you some storage solution over the internet. You're able to take pictures or videos or take notes and these things, and they'll be synced across your devices simply through your account information over the internet, without you having to actually own the hardware that is storing those files in the case of Google Drive, or owning the hardware that's backing those files for them to be on your multiple devices in the case of iCloud. But the important thing to understand with cloud, and the reason that it's hard for most people to wrap their heads around what a big industry it is that it's not just about storage. That's usually what people think of when you mention cloud, because that tends to be the most and sometimes the only really consumer facing portion of the cloud, whereas the rest is maybe just software engineers selling software to software engineers. These examples that I've given are simply storage. We'll get into some more examples of what can be built in the cloud throughout the rest of this presentation. So what is AWS specifically, which we interact with the most as a cloud provider? That is Amazon Web Services. So that's specifically Amazon. You're probably familiar with Amazon.com, doing retail and online shopping with them. But actually a huge portion of their business is their cloud services, AWS, whereby they provide different services like not storage, but also hundreds more to build on the cloud. Another common application for building something on the cloud is a web application, right? So any sort of application that you're seeing where you visit some URL, there's some message passing back and forth, and you're presented with some application that you can interact with, would be a web application. That's another common application for the cloud that maybe some people would be familiar with, that being backed by cloud. But again, that's just one more in a series of hundreds of different applications. So on AWS, you can do things like machine learning, data analytics, there's security, there's storage, obviously. There are hundreds of applications. Why do we use the cloud though? Obviously, you can build those softwares not delivering them over the internet. There are a few very key reasons that we'll get into here, but there are many more. The first one would be elasticity. So scalable resources. The idea there is that a company like AWS is going to have tons and tons of these data centers, as you can see a picture of that on the right. And they're going to have available capacity for you to be able to scale your resources with demand, and scale back with demand as well. And that's much better than the previous model before cloud computing was very popular of reserving, let's say 2, 3, 4 years and having wasted capacity or not enough capacity, having to maintain hardware as a company that maybe doesn't actually do that. It's very tiresome. Flexibility. So the ability to pay only as you use and for what you use. So the idea there is that if I'm able to match my demand more with my capacity, as is stated with the elasticity point, then I'm able to pay more along the lines of what I'm using in terms of IT resources, as opposed to what I predict that I'll need. And that provides me with some flexibility in terms of cost. The other tenet of this point is the idea that AWS has very specifically laid out and well-defined tracking metrics for your usages that you can understand, and then those tracking metrics make it easy for you to see that you're paying only for how much of the resources that you actually consume, as opposed to what you might consume or what you contract for upfront. The next idea is agility. So these data centers, these servers are all over the world, and you can easily globally deploy in different places in minutes. So when you go on the AWS console and maybe spin up some servers in a data center, it's as simple as selecting where in the world you would like those servers to be, to go global, as opposed to before, where you'd have to actually stand up servers in a specific location. The other part of this is security. AWS data centers, and for that matter, by the way, I'm talking a lot about AWS. There are other cloud providers, primarily Amazon's AWS, Microsoft's Azure, and Google's GCP. All three of these companies are going to have very high security in their data centers, and you don't have to manage that. So that's a very valuable thing. They're also going to have audits that are done by third-party companies that are by law not associated with those companies, that will certify them with certain levels of security and compliance. And that's something very useful, and assurances that you can get with cloud providers for security purposes. As maybe some company that doesn't do anything related to software, you don't want to risk putting your users' security at risk. So this is a very useful thing for you. Okay, practical example, something a little bit more fun for why maybe you might want to use the cloud as just a group of friends. So what if you want to run a super cool Minecraft server? If you not familiar with Minecraft, it's just a game. You can start up the game, you can walk around, break blocks, place blocks, build things, and that's kind of the idea. And it gets really fun when you can play it with other people, especially your friends. So let's say that you had a group of friends, like 10 friends, and you wanted to go ahead and start up a Minecraft server. Well, you want to be able to support that Minecraft server 24 hours a day, 7 days a week. Reason being that you want anybody in your 10-person friend group to be able to log in at any time, different groups of people to play at their own leisure. That would mean running your computer for that period of time. And let's say you just put that in the corner of your room and run it. Well, it's going to cost you a lot of electricity. You're not going to have resources to necessarily scale, especially a 10-person Minecraft server is going to be a lot of resources. You're not going to have cooling in place. You're not going to have redundancies. The data is not going to be very safe. And overall, your hardware costs are a lot higher because you're unable to buy in bulk like a company like Amazon, Google, or Microsoft is doing at any given time. So overall, it's going to cost you way more. It's going to be less reliable. It's going to waste your space and your time. And it's not even guaranteed to work. So instead, you could use the cloud. You could provision some of these resources from a cloud provider like AWS, like Microsoft, like Amazon, or like Google, and it would cost you less. This equipment is specialized and designed to run for 24 hours a day, 7 days a week. There are backups. There are different locations. If one goes down, you can pivot to another one. They are buying in bulk. They have cooling. All these advantages come from that. Not to mention the other stuff that we talked about before. So even as small users all the way up to enterprise level concerns, cloud has a lot of benefits. And so we've just talked about two uses here again, right? Storage and servers, which called compute in cloud computing, but we haven't scratched the surface. And there's a lot more that exists here. We're going to run through a few basic AWS services, kind of just some tools that you can use to build some cool stuff. But again, there's hundreds, so there would be no way for us to go through all of them, but just a few basic ones for your knowledge here. So the first one that's probably the most important for just even using AWS is IAM. That stands for Identity and Access Management. So this is one of AWS's security services. Specifically, this is the one that manages who has which people and how much access they have within your AWS account to building things and running things. Extremely important because it's very easy to very quickly waste a lot of money with a cloud provider because they have plenty of things that will cost. Yeah. Sorry, is there a question? Okay. Yeah, so it's very easy to very quickly waste a lot of money with a cloud provider, spin up some resources, and so it's very bad if you have some insecurities with regards to identity and access management. So this is a good one to learn right away first. So say, for example, you're running a website. So your company, you have a website, you have some teams of developers who are working on that website. And each user has their own login information, but they're under a larger organization, which is going to control their permissions. So you can see kind of in this diagram for, let's say, account A, you have a group of engineers who are logging in under an IAM user group. So I can assign some permission to some different groups. So for example, I could have a group of engineers, a group of business people, a group of data analytics people, a group of accountants. So perhaps the accountants would need access to some of the billing and management cost services that come under AWS, but maybe they don't need access to some of the other services where they can build servers or use up storage space, because obviously as accountants, that's not really under their job description. Whereas engineers maybe need more full access to some of the more technical aspects of the AWS platform, but maybe they don't need access to some of the accounting information or any of the like billing information for the company. So that's how we can sort of delegate some permissions in groups of users as a website with these teams. There are also service roles. So for example, if you have a few different services built into a somewhat complicated topology that you need to run on AWS, perhaps one service needs to programmatically access another one as opposed to a user doing it. So we can also assign permissions to given services within the platform. Gets a little bit more complicated, but for now, kind of the main idea here is this is going to allow us to delegate very specific permissions to different users and services within AWS for their abilities to access other resources. Okay, the next service would be Amazon VPC, so it's virtual private cloud. This is another one to know right away because this is going to manage the vast majority of your networking. And we mentioned in the first slide, right, that cloud computing as a whole is the delivery of IT resources over the internet. So the internet is quite an important aspect of this. So VPC is a virtual cloud network within which you launch your resources. So if you're familiar with IP addresses, firewalls, with load balancers, with subnets, these sort of things, this is all going to be contained within this service. So the first thing you do is you specify an IP address range for private networking that's within your network. So for example, if I'm sitting in Berkeley, for example, and I'm connected to the Berkeley network, within the Berkeley network, communications are done locally with private IP addresses. So if I'm sitting in one hall in Berkeley and I'm communicating with a server that is sitting in another hall in Berkeley, there's no need to go out onto the public internet for those systems to talk to each other. They're sitting on the same private network. So the first thing is to do is specify that range. On AWS, firewalls are called security groups. A little bit too complicated to get super into firewalls and how they work in this, but that's just what they're named. And public subnets, so there's a concept of public and private subnets. A subnet is a collection of IP addresses. So you'll have some number of IP addresses that you can assign to devices within that subnet at any time. And you can move devices in between subnets if you like. And there are public ones, so ones that maybe need to serve traffic. So for example, if you are Google, you may want some subnets that are public, servers within those that are actually serving internet traffic from users who come to search for something. On the other hand, you are also storing very sensitive user information, like for example, Gmail login details. So when someone tries to log into their Gmail account, you can verify that they have entered the correct password. You're probably not storing their actual password, it would be terrible security, but you're storing some representation of their password, which you can use for verification when they're logging in. So what you would want to do is you would want to have that sort of information being stored in a private subnet, whereas you would want to have your web traffic public-facing servers in a public subnet. And so that's made possible with something called an internet gateway, which you can place into a subnet to make it a public one. Private subnets, however, so for example, back to our Google example, you would have, let's say, this database of user information. You need to still apply operating system patches. You need to still access the internet from that subnet. You just don't want anybody from outside coming in and starting a request with you. So you have something called a NAT gateway. So this allows you to do internet access out, but without additional configuration, internet access in will be blocked. So you can set up a VPC like what we've shown here, one VPC per region. So a region could be something like, let's say, Northern California, or I could have another region in Virginia or in somewhere in Europe. And each of those regions would have its own VPC, its own range of private IP addresses. And within those, I would set up these subnets. And then within those, you can see their servers. Okay, so Amazon S3, this was the first service that actually launched with AWS. It stands for Simple Storage Service. So this is a service, obviously Simple Storage Services, it's a storage oriented service. So this is kind of more of what we were talking about at the beginning. Something like iCloud could be backed by this. In fact, Apple actually uses Google Cloud Platform, so it wouldn't be AWS, but something like that could be backed with a service like this one. So within S3, there are a few kind of key things that you can talk about. It's an object-based storage, which means that you upload, it's less like a hard drive as what you would have in your computer, and more like you can upload, it's more like Google Drive, really. You can upload documents, files, objects as a whole into this storage and blocks, as opposed to having access to the files themselves for editing purposes, which you would get with actually opening them in Google Drive. So this would be more like just storing them. So objects are files and information about those files. Information about a file is data about data. We call this metadata. Buckets are collections of objects. You can think of a bucket as a single drive, although it's not the best analogy because a drive has a limited amount of storage, whereas a bucket will store as much stuff as you put into it. It will continue to scale theoretically infinitely. You would be hard pressed to use up all of the storage available to AWS before they build more. There is a concept of folders. So for example, I could make a photos folder and put some files into it. And it would be contained in a way that emulates what folders are, although technically they are not what are traditionally known as folders, because again, this is not a hard drive. Again, so I mentioned storage is limited. There is 99.99% durability. We call this 11 nines. Durability as a term is actually very specific. And what it means is that if you lose access to a file, what the probability is that you will at some point, some reasonable time frame, get that file back. It's different from if your site went down, you would be able to bring it back up in a short period of time. We call that availability. So given this probability, you will really probably never lose your files. And then interactions with objects, sorry, no, it's fine. Interaction with objects is done using HTTP requests. So if you're familiar with HTTP and how those requests work, then you know what that means. But obviously you don't have time to go into HTTP right now. Okay, Amazon EC2. EC2 stands for Elastic Compute Cloud. This would be another one of these really essential services provided by AWS. And this is what you might use to do something like the Minecraft example, where you need actual computers running that have processors and memory and these sorts of things. So you provision servers are called instances when you're doing cloud computing. You can think of it like another computer or another 100 computers, depending on how many you're going to provision. And there are different instance types. So these are various configurations of CPU, memory, storage, and networking capacity. And you can think of that like, instead of, you're sitting down and you're building your own computer, so you're choosing between different processors and all this, you're buying like laptops, right? And there are a certain set of offerings of CPU that comes with certain amounts of memory, and you can do some configuration there. And so there are different sets of resources that are offered to you in blocks at different price points and different amounts that you're able to provision. Okay, then there's something called secure shell. Secure shell, if you've ever taken your computer and gone to terminal or PowerShell, or depending on what operating system you're using, could be one or the other or different ones. That is where you can issue commands and sort of have, you can think of it like a sort of conversation with your computer. You can issue a command, it will try to run it, and then it will come back to you with the results. And this is kind of how computers worked before you had a screen and different ways to interact with them. But it is still a very powerful method of controlling a computer remotely. So for example, if I provision some servers, sort of instances, using EC2 through AWS, my access to those servers would be, the most basic method of doing so would be using SSH, which would give me this sort of command line interface, which is what CLI stands for, with those instances. And that uses encryption keys and all sorts of security measures to make sure that you're talking to those servers on an end-to-end encrypted line. Security groups, again, as I mentioned, are firewalls, but we won't get into too much of that. And each EC2 instance will come with a private IP address by default. So as I mentioned, that's kind of your identifying kind of address, like a home address for your computer within the local network that it exists in. Amazon Lambda. Lambda is very commonly used service, a little bit newer than some of the other stuff we were talking about so far. Lambda allows you to run code, but without a server. So a server is kind of something that you're trying to get away from in industry these days. So for example, you might have some application that you run a server 24/7, like a Minecraft server. That's unavoidable. But if you have an application where you can instead spin up servers to take care of a request and then spin those servers down and do this on demand as requests come in, then you're able to much better take advantage of that idea of flexibility, as we mentioned earlier, and paying for specifically how much actual usage that you're going to need instead of uptime, where the server is not actually serving requests. So this can be really good for connecting some services together or managing some kind of backend, where you can set up something called a trigger. And so activating one service will trigger your code to run, which maybe activates another service and goes down some other chain of achieving your goal. So for example, this architectural diagram that's been provided at the bottom here, you may have a photograph taken with a camera, and then that's uploaded to an S3 bucket, which, as we talked about, is an object-based data store. So you can put that photograph into that S3 bucket, and that will create an upload event, right? So the event has occurred, you have uploaded an object, and you can configure that as a Lambda trigger. And so this Lambda function will be triggered and it will run. And perhaps, obviously, given that it's triggered by the image being uploaded, we assume you're doing something to that image. Let's say, for example, that image is being resized. Perhaps you're taking that image and turning it into a thumbnail for a YouTube video. So this might be something that YouTube under Google would need as something built into their cloud. So perhaps you have that Lambda function resize that image into a thumbnail sized image, and then send that somewhere else to be rendered for the user who is creating that video before they upload it, to see what they think of it. So you can see the services working together. You can see that Lambda is being triggered by event when you actually need code to be run, as opposed to being up and running all the time. We call this serverless architecture. Another thing to quickly go back on, or to go back to here, is IAM, right? So the idea that services calling services programmatically, as opposed to just users needing to interact with services, is being illustrated here. In this example, Lambda would need some permissions to go into that S3 bucket and look at that image object and resize it and send it somewhere else. So we would do all of that with IAM. And AWS provides hundreds of services. You have to find the ones that fit your needs, not only financially, but also computationally. And obviously the basic function of that service should match what you're trying to achieve, and putting them together into a solution. is called solutions architecture. And this is kind of, we're getting kind of a better picture of what cloud computing is actually all about, as opposed to just storage solutions, server solutions. It's models of huge interactions between many different services to achieve entire platforms. Okay, so we can run through a quick console demo. While I'm actually setting that up, if there's any questions, I'd love to answer them. And also we have until 6:30, yes? Or 6?
Yes, until 6:30.
Okay, yeah, we might have a little bit of extra time left. But yeah, if there's any questions, please ask them. Okay, so this is the landing page. And let me just do a login here. Okay, so now we're logged into the AWS console. And this is where the magic happens. This is where you actually build things using the cloud. So you can go ahead and click here to see all the different services that are available. And this kind of illustrates, as I was talking about earlier, there's a lot of them. And even if you look for just specifically kind of the headers of what services are available for different tasks, under storage, S3 is first service that was ever introduced and most commonly used for storage purposes. But there are also other ones that do different things and are useful for different reasons. Under compute, we can see EC2 here that we talked about, but there again, a lot more. Lambda that we talked about. Again, a lot more that we could have gone over. So the first thing that we'll want to maybe look at on the AWS console is S3. It's easy to demonstrate. So you can see any given configuration for AWS. Well, not any, but most configurations that can be done for AWS can be done in the console using just clicks and configuration and very little coding. Which makes it accessible for people who maybe aren't as technical or computer science oriented. So for example, if I wanted to create a bucket that could store some objects, I could just click here, create bucket. I could give it some name. So test bucket. The name has to be globally unique, so I'll give it some gibberish at the end to make sure that's achieved. This is an illustration of our of the global reach. Here we can place these servers in many different locations around the world. I will place these in North Virginia, for example. And then I will click create bucket. The other thing to notice here is that a lot of this stuff at least has some default setting that's already activated. And those default settings are security oriented. So the effect of that is lowering the barrier to entry for usage of things like these services, because you can very effectively create something in a minute or two and then sit down and tweak things and get more technical when you actually need it. So here, just creating a bucket out of demonstration can be done in like 1 minute, as I've done it here. And then I could immediately start uploading some files to this bucket, and it would store them. It would scale infinitely, as I talked about, and I could use this in numerous different ways to build tons of cool stuff. Another service that we could look at, EC2. EC2 right now, you can see there are no instances running on this account, but we could click on launch instances and we could change that. So the first step would be to choose an AMI that you can think of that as simply an operating system. I'm going to select Linux, which if you're not familiar, don't worry. The main thing I want you to see is the instance types. So they have families, names, these all mean things. But the important thing that I want you to look at right now is the number of virtual CPUs and memory that you're getting. So for example, this very basic server here is one virtual CPU, 1 GB of memory. But if I wanted something that was much beefier, I could have it. If I wanted, for example, this 72 core virtual CPU and 192 GB memory instance, I could spin that up. There are tons and tons and tons of different offerings here that you could potentially use. Now, one thing to notice with this T2 Micro, 1 vCPU, 1 GB of memory, is that it's free tier eligible. And this is another illustration of that low barrier to entry that I'm talking about here. Many services will actually offer some free tier of usage for however long, like they can be infinite time. For example, Lambda has 1 million free invocations per month forever. So you can very easily build a website or something with Lambda that is completely free for the foreseeable future, unless you get a lot of users, at which point perhaps you have money to spend. And in this case, there is, for the first year of opening your account, the ability to use 750 hours of this type of instance per month. And so after that, you would pay the normal fees. We can next configure some few details. So for example, instead of 1 instance, I could, for instance, put 400 here. I won't, because that will cost a lot of money, but I would just put 1. But that is easily done here. And something that, I mean, before cloud computing, that would have been absolutely insane to be able to work between 1 and 400 times that many, just with 1 configuration in a box. There's tons of other information that we can configure here. I've spent a lot of time understanding it all, but again, it's all given in default. So if I wanted to, I can just click on next and not have to worry about what any of that stuff is doing. The next thing here is storage. It's going to by default create a very small hard drive for me that just contains my operating system and just critical information for my instance to run. And I've spun up plenty of instances just with this, with small tasks that they do. But if I wanted to, I can add larger, let's say 500 gigabyte drive here. Just an HDD drive. I could add that. I could tell it to be encrypted. I can do a lot more configuration on the on the hard drive itself. For this particular demo, we won't add any actual extra hard drive, but I just wanted to illustrate you can do that. And many more than just 1 extra hard drive if I wish. And those hard drives can be resized later as well, which is an advantage that's offered to you by the fact that there's some layer of abstraction between you and that hard drive, which is where AWS sits. And you are gaining access to that as a virtualized hard drive. So because it's not technically exposed to you as a physical device, it can be resized and can be flexible in different ways. Security group firewall configuration, we're not going to mess around with it, but again, that's something that's pretty essential for doing EC2 development. So we can review and then launch. And I'm going to just set that up. And we can click view instances, and we can see that this instance state is pending. Over the next probably minute or 2, it will go from pending into the running state. And so that is how quick and easy we can just create a new server on AWS. Similar process would be involved for any other cloud provider. And so that's very fast and very configurable, but also with a low barrier to entry, we're able to do it quickly if we like. So that's what's being illustrated here. You can see that's running now. So I would be able to then, if I'd like, SSH into this instance and have it do something, for example, run a Minecraft server, and then we could play on it. This instance by itself is pretty weak, so it probably wouldn't run very well, but I could make a bigger one, or I could use multiple. There are different solutions that I can come up with for how to deal with that. The last thing that I think I'll show you will be outside of the AWS console, and that will actually be the AWS pricing calculator. this will help me illustrate a little bit about how the pricing itself actually works. So the AWS pricing calculator is a very useful little tool that you can use to put together a bunch of different services and predict how much usage you're going to have with them and understand what the cost would be associated if you're correct about those predictions. So for example, I could say that I am going to be getting an S3 bucket. And let's say I'm putting that in Northern California. And I'm going to say we use 1,000 gigabytes per month of S3 storage. So that's 1 terabyte of storage. And then I'm just going to put some information in here, which essentially just means how much data is being put into the bucket, copied into other buckets, posted other places, deleted from the bucket. These are called requests against that bucket, and how much data is actually over the internet going into and out of the bucket. And I can click on show calculations here, and it will tell me exactly how it has come up with a price of $35.17 monthly for this S3 bucket. And this is illustrating what I talked about way earlier, I think second or third slide of this presentation, of very well-defined usage metrics for doing pricing and how those metrics are priced that are also tiered so that as I use in bulk, I'm going to save. And so that helps me to be assured that I'm paying for my usage and not just for something that's predicted. So I could, for example, add this to my estimate, and I'm getting kind of a portfolio in which I can add more services and other usages to build an entire topology, which, as we talked about, is the true power of cloud computing, is when you put services together. So if, for example, I also had an EC2 instance with 4 vCPUs and 16 gigabytes of memory, which would put me in this instance type, and I had, for example, 10 of them, and I'm using them 100% of the time, they're always up, and they have 30 gigabytes of storage each. I can add that to my estimate. Those cost me $771.11 monthly because I have 10 of them. Obviously, it costs a lot. And so it'll give me a total 1-year cost of $9,675.36 for this topology. And obviously, I can configure much further. I can use different services and get a very like exact estimate of, based on how accurate my predictions are of usage, how my costs will look on the AWS environment. And I think that is pretty much it for what I wanted to show. If there's any other questions, or if anyone wants to see any other services, we can take a look. I'm familiar with quite a few of them. Or just any questions about anything. Is there anything that you wanted to add, Olivia, or anything that I missed?
I don't. Oh, there's one more slide on the slideshow.
Oh,
it's
right.
just a conclusion slide. So
here you go. So conclusion slide. Thank you for coming to our demo.
oh, you're not sharing it.
Oh, okay, my bad. Can you see? Yeah, okay, cool. So thanks for coming. If you want to learn more, you can go to cloudacal.com or follow the Instagram or Facebook. You can reach me at hamzamk@uci.edu and Olivia at ohuang@berkeley.edu and through Slack DMs. And like, I'm happy to answer any questions about AWS or like anything that you need. And AWS provides free tutorials for most of their services and have extra tutorials for certifications. If you're a student, you can go to this website to learn more about that and sign up for that. And the education branch, which Olivia and I run together, teaches a new cohort of students cloud basics every semester. And the applications will open up again in the spring. So we would love to have you.
All right, thanks for the very informative talk. I guess we can end it there if there's a last call for questions. If there's no questions, then we can end it here. All right then. Cool.